Hello everyone, welcome back into the another session on software testing. Students, since last couple of lectures we are discussing about the static testing. In the static testing we discussed how the testing will be carried out without executing the software. In the last lecture we studied about the reviews. So there are two different sorts of reviews which we can perform on software. The first one is formal review and the second one is informal review. So formal review is also called as a inspection. So in the formal review you have a proper settings for the review. You will have a project manager who has laid out the plan for the review. Then you have a moderator who will facilitate the entire review process. Then you will have an author or a developer who will be presenting their software. Also, you will have a recorder participating in the review process who will record the entire activities which are being discussed in the review. So that is called as a formal review or inspection. The other type of review that we discussed in the last lecture was informal review. That is also called as a walkthroughs. So these are the reviews which are very informal in their nature. So here you will not have a third party moderator or any professional moderator. Instead you will have a software developer or a software author to describe the entire process of the review. So here the author will explain entire things about the software and he will be moderating the entire review process. So that is called as a informal review or walkthroughs. Next you will have a technical review. Now in the case of technical review, technical aspects of the software are tested. So here you will need professional software developer or experienced software developer who will be assisting as a technical reviewer. So the sole purpose of having this technical review is to check your software on technical aspects. Now there are many times you are implementing a software which is using a new technology, or there are new concepts are being implemented. So in that case the technical feasibility of the software cannot be told in advance. So that's why these technical reviews are essential. So in the case of technical review, specifically software will be tested and looked upon based upon the technical expertise of the reviewers. So the reviewers who are very technical expert or who has a knowledge of that particular technology will observe your software and will go through the entire software to find out technical glitches if there are any. And based upon that they could suggest different suggestions or different improvements for your software in technical point of view. So those are called as the technical reviews. Next concept that we are going to discuss today is a white box testing. Now consider your software as an entirely transparent box. So what you will see inside? Obviously, if it is a transparent box, you will see inside the different codes which are written for the software. You will see the internal paths in the software, you will see the internal structure, and then you will see different conditions that how your software is handling. So white box testing is a testing wherein you will see the internal structure of the software and based upon that you will design certain test cases. Now why do we need to have this white box testing? If let's say suppose you have a software in front of you, just by providing an input and looking at the output you can see whether the software is working properly or not. So why is it really required to see the inside of the software to test it? So the reason behind that is because many a times you miss certain cases which you cannot see apparently a problematic into the software. So when you will have the internal structures access, when you will see the internal code, many times you can design the test cases by having that knowledge and then you can successfully break the software. I can give you a simple example for that. Let's consider you have designed a calculator. Now in the calculator, if I will enter some calculation like 1 plus 1 or 1 minus 1, I am getting a right output. So can I say that the software is alright? Probably the software is alright for the addition and subtraction. But let's say suppose I am performing a division and 4 is getting divided by 2. So the obviously answer should be 2. After performing this calculation, I am getting a 2 as an output. So any programmer or any software tester can assume the software is working properly in this particular case. But when you will have the internal access of the software, when you can see the internal code which is written in the software, you can design number of test cases which can break your software. For example, if I will try to divide 4 by 0, then what is going to happen? Certainly your software will interrupt over there and it will cause the error and abruptly it will stop its working, isn't it? So in order to avoid those conditions, you should know the internal structure. Now if you know that we cannot divide any number by 0, and when you are having an internal access of the software, when you can see the code, you will obviously try to observe that thing, that when you are trying to divide by anything other than 0, then what will be the outcome that you will see. And when you are trying to divide anything by 0, then how your computer or how your software is handling that scenario, that you can understand. If some exception handling is done over there, then you can safely assume that this software is working perfectly. Even though you will try to divide anything by 0, it will give you the proper output or an error message and it will not stop abruptly or it will not crash. But if you don't have the internal access, then certainly you might not get this particular condition and you can safely assume the software is working properly. So for that particular purpose, it is always essential to have the internal knowledge of the software, and that knowledge you have in the white box testing. So in the white box testing, you will see the internal paths, you will see if-else statements where the conditions are flowing through, you will see the internal structures, and as an experienced software tester, by looking at the code itself, you can figure out the problems, you can figure out the bugs in your software. So that's why white box testing is essential. This testing is also called as a structural testing or a clear box testing or a glass box testing. The reason is that you have the access to the internal structure of the software. The entire software is treated as a glass box, so you can see the internal mechanism of the software, and based upon that you can design test cases. But in this case, you will require a detailed programming skills, because without having the knowledge of the programming, you cannot execute any test case or you cannot write any test case. So for that particular purpose, you should have a programming knowledge before you will go for the white box testing. So most oftenly, the person who is performing white box testing are a senior level programmers who have already worked on that software programming and they know how the software works, they know the outer structure of the software also, and they know the internal working of the software also. So this is how this white box testing goes on. In the case of white box testing, you are designing test cases by considering independent paths inside the module. So you exercise all independent paths which might be there in your software, and you will try to explore each and every path. You will try to go through each and every path so that you will figure out whether there are any bugs on any of the paths or not. Now how you will determine how many independent paths are there? So for that particular purpose, you should have the internal knowledge of the software, and that's why it is called as a white box testing, and that's why you have the internal access of all independent paths which are there in your software, and by having the knowledge of those paths, you will see the code and accordingly you will try to design test cases which will execute all these paths independently, and then you will see whether your software is working properly or not. Many a times, let's say suppose in your software you will have hundreds of paths because permutations and combinations are too many. So in that case, you have to only identify the important paths from start to end, and that you have to execute. So that is called the independent path testing. Then you have logical decisions. Suppose if you will have the if-else condition within your software, then you have to evaluate that logical decision to the true, and then you have to see what are the outcomes, what is the output. Then again you have to evaluate that condition to false, and then you have to see the outcome. So here the test cases are designed so that At one instant, logical decisions will be considered as a true, and at another instance, the logical decision will be treated as a false. So you have to design the test cases in such a way so that logical decisions will be evaluated to both true and false at any particular time to see what are the impacts of that logical decisions on the rest of the software. Also, you have to look and explore all the loops which are there in your software. So when you are executing the loops, you have to look at the boundaries. So if I am saying, if I have to accept the number, let's say suppose students marks from 0 to 5, then you have to always understand how these boundaries are working and whether the boundaries are properly protected or not. What will happen if we will touch to any boundary, whether your software will fail or not. So that you have to check. So that is the loop testing or the white box testing under which you are executing the loops. Then you have to exercise internal data structure to ensure their validity. So that is, you go through the entire data structure, how the data is flowing through your software, where the data is being modified, how it is being modified, that you all observe, and based upon that you design the test cases. So all in all, in white box testing, our major focus is on the internal components of the software, and based upon the internal components you design the software. Now obviously when we talk about the internal components, there is a certainly you will have the different paths existing or available in your software. You will have the logical decisions, if else available or switch available in your software. Then again you will have some iterative statements like loops will be available in your software, or many times you will have a particular data structure which you have created in your software. So all those things you have to see, you have to observe, and having the knowledge of those things you have to design the test cases so that effectively you can break the software or you can find out the bugs in the software. Here are some techniques through which you can perform the white box testing. So the first one is control flow testing. Now as its name is stating, control flow, here you have to observe the flow of your control in your software. So right from the entry point of your software, how the control is flowing, whether control is reaching to the end of the software in a proper way or it is abruptly terminated somewhere else, that you have to observe. So you have to evaluate all the paths over here, all the control paths in your software to test whether the control is being flown properly or not. So that is called as a control flow testing. Later on we will see the control flow testing in detail, of course. Then next we have a data flow testing. In the data flow testing, you have to observe how the data is flowing through your software from starting point to the end point. So the point from where the software data is getting inputted into the software, from that point how the data is being modified, how it is being accessed, how it is been stored, how it has been retrieved, and in which particular format it is being presented again to the user, that you have to observe. And by having that knowledge, you have to design some of the test cases which can reveal the bugs in your software with respect to data. Then you have a coverage testing. Now coverage testing is a sort of testing wherein you will try to achieve maximum coverage. How you will achieve the maximum coverage? So maximum number of lines that you wanted to touch upon and you wanted to execute in the coverage testing. So let's say suppose you have a software wherein 1000 lines of code is written. So in the coverage testing you will design your test cases in such a way so that maximum lines of code will be evaluated and maximum lines of code will be executed. Now for that you might need to enter some different control. For that you might need to enter some different conditions so that maximum coverage will be achieved. Generally 70 to 80% of the code should be tested in the coverage testing. So this is how these three different techniques which will assist you for the white box testing. Here we will stop today's session. In the upcoming session we will discuss about the control flow testing in detail. Till then, keep studying. Thank you.